Hey everybody, let's look at this one. Here's another example of an angled projectile problem. So let's say you launch a cannonball and it travels 100 meters horizontally. So we got that labeled right here. You time that the flight, you time the flight, that should be fixed, as 10 seconds. So it was in the air for a total of 10 seconds. So we're going to find the following. A, the horizontal velocity. B, the initial vertical velocity. C, the magnitude of the overall initial velocity, and D, the angle of launch. Okay, so let's do part A first. So what do we know horizontally? We know that the x displacement is 100 meters. We know that it took a total of 10 seconds to go that 100 meters. So we simply plug it into this equation right here for average velocity. So the x velocity will be the x displacement divided by the time. So 100 meters divided by 10 seconds gives us 10 meters per second is our horizontal velocity. And remember, that was constant 10 meters per second the whole time. All right, what about the initial vertical velocity? Well, we know it was in the air for a total of 10 seconds, so it must have only taken 5 seconds to get to the peak. That means that our initial y velocity must have been 50 meters per second. So the first kinematic equation can prove that to you, but you can also reason it out as well by taking off 10 meters per second each second. So let me go back to that 1 second. So our initial y velocity was 50 meters per second, but remember, that begins to change the moment you shoot it up. So what about C, the magnitude of the overall initial velocity? Well, we know it's going to the side at 10 meters per second, and we know it's going up at 50 meters per second. So we can find its overall velocity by using the Pythagorean theorem. So 10 squared plus 50 squared, take the square root of that, and you get approximately 51 meters per second there. So last thing here is, what's the angle of launch? What was this theta right here? How many degrees was that? So we can use one of our trig functions in order to solve for this theta here. So I'm going to use an inverse tangent. So tangent's opposite over adjacent. So 50 over 10. If I take the inverse tangent of that, it will tell me what angle gives me a tangent of 50 over 10, and it is 78.7 degrees roughly is that angle. By the way, what angle would you want to shoot this at in order for it to go the farthest? Let me actually back up here a bit to earlier in this presentation. So the angle that will make you go the farthest is actually 45 degrees. So 45 degrees will give you the maximum amount of range. If you look at this graph right here, it's interesting. Complementary angles have the same range. So 75 degrees and 15 degrees will land at the same spot. Likewise, 60 degrees and 30 degrees will land at the same spot. So why is that? Well, 75 degrees has a bunch of vertical velocity. So you get a bunch of hang time. That's good. But it doesn't have a lot of horizontal velocity. So you're not going that far to the side with that hang time. Now, 15 degrees has a lot of horizontal velocity. So you're covering a bunch of ground every second. But you don't have hardly any vertical velocity to give you hang time. And it turns out those two things will exactly cancel each other. The additional hang time for 75 degrees is perfectly canceled out by the lack of horizontal velocity. So you land at the same spot. So any two angles that add up to 90 will add up at the same spot. So 45 degrees is the perfect mix of vertical velocity to give you hang time and horizontal velocity to give you range there.